Hello everybody, welcome back to the channel. I hope you are doing great today. So now we'll be looking at a winter paper from 2023 paper 1-3, and specifically we'll be looking at question 11. Okay, so they said that a uniform rigid beam of length 3.2 meter is pivoted at its center. Two children sit at the opposite ends of the beam as shown. So basically this is something like a seesaw, right? So then they said one child has a mass of 24 kg, the other child has a mass of 26 kg. Okay, the heavier child causes one end of the beam to permanently rest on the ground so that the beam makes an angle of 20 degrees to the horizontal ground. So they are referring to this child. Okay, and the question wants us to find the moment of the weight of the 24 kilogram child about the pivot. So before we answer this question, right, it is important for you to know what does moment means. So moment has a formula of force times distance, right? And the force and the distance has to be perpendicular to each other. That is something very important you need to take note of before answering this question. Okay, so let's see what information we have here. So they say that the distance is 3.2 meter. Okay, and since it's pivoted at its center, that means they are, when we divided them into two, they have equally 1.6 and 1.6. Okay, and we know this is the weight of the child, right? mg, which is 24 times by 9.81. And as I said just now, the distance has to be perpendicular to the force. So what distance in this case would be perpendicular to the weight? It would definitely be this, right? From the pivot to the weight, because they asked the moment about the pivot. So how do we find this distance x? Let's say I label it as x. If this is 20 degrees, wouldn't this also be 20 degrees? Right? And we know this distance in 1.6. So this is basically Pythagoras theorem. So if I draw the triangle here separately, okay, that is not a triangle, wait. Okay, something like that, 1.6, and this is 20 degrees, and you want to find, let's say, this x, right? Because if this is x, then this should be x as well, am I right? So x. So we realize this is actually using cosine. So cos 20, because cosine is adjacent over hypotenuse, right? This is your adjacent, this is your hypotenuse, equals to adjacent over hypotenuse. And when you take your calculator and compute this, you should get. Also, when you're calculating using your calculator, make sure your calculator is in degrees and not radians. If it was in radians, you're going to get a totally different answer. So your x would be 1.5035. Like I always said, any in between values, always put to at least 4 significant figure, or you want to put as 4 to 5 decimal place. Only final answer, you round it up. If the answer was rounded up to 2 significant figures, okay. If it's not, then just give as it is lah, what your answer is. But in between, make sure you give 4 to 5 decimal place or 4 significant figures. This is to ensure accuracy. Okay. So now, to find the moment, we can just take the weight times by 1.5035. So your weight is 24 times 9.81. Remember, it is 9.81 in physics paper. If it's in mechanics paper, then it's 10. So make sure you use the correct G value. So if you compute this in your calculator, you should get 353.98. Basically, it's 354 Newton. And if you realize all the answers here are in 2 significant figures, therefore, if you round this out to 2 significant figures, it's 350 Newton. And your answer is C. So, is there another way to solve this? Yes, there's actually another way to solve this. Okay, let me erase all this first. Okay, erase. Oops. Okay, maybe not erase the working here. Okay, Okay, I'm going to use a different color so that to show it's another way to do this. Okay, another way to do this is using resolution of forces. So we know this is the weight, right? And if you're going to use weight, then you have to take this distance because that is a distance that's perpendicular to the weight. But if let's say you want to use this distance, 1.6, let's say you did not see that the fact that it is possible to be 20 degrees here in exam, you did not realize that, it's okay. There's always an alternative. And you notice this 1.6. So now, if you notice this 1.6, you're going to find a way to find the force that is perpendicular to this 1.6 distance. And that would be this. Am I right? And if you realize, this is actually where the resolution of forces come in. So this whole thing here, let me highlight in here. Okay, that's a very big highlighter. Highlight in yellow here is actually a right angle triangle. Okay, I think I should use blue. Cannot see. Okay, this is actually a right angle triangle. So if this is 20, this is 90, what is your angle here? 70 degrees, right? So, therefore, this will be W sine 70 degrees. The one that is parallel to the distance of 1.6 will be W cos 70 degrees. In this case, since we are finding the force that is perpendicular to 1.6, therefore we take W sine 70 degrees. So that means your moment would be W sine 70 degrees multiplied by 1.6. And this is 24, 9.81 sine 70 times 1.6. You would get the same answer ideally. But I will just calculate it just in case to make sure that we are doing the right thing. Yes, you get exactly the same answer. And round out to two significant figure is 350 Newton. 350 newtons. So both gives you the same answer. So if you ask me, honestly, which method do I personally prefer? I don't really have any preference because both ways doesn't take a lot of time actually. Both ways are reasonably almost the same. It's just your perspective on what you see. So initially, I actually saw this method first, the second method before the first one. So I did the second method first. So actually both gives you the same answer. What matters is you know what moment is. Your force has to be perpendicular to your distance. So let me tell you what happens if you forget that the force must be perpendicular to the distance. Okay, let me erase this. Because Cambridge is also smart. They will also put the incorrect answer in the choice of the answer because they think you won't realize it. So let's say you take this weight here. You did not realize, okay, that the distance is not perpendicular. You just straight away take 1.6. So your working would be W times 1.6, which is 24 times 9.81 times 1.6. And your answer would be, okay, let's put it 376.7, and to two significant figure, this is 380 Newton meter. Oh wait, I just realized, oh my god, I'm so sorry. This has to be Newton meter and Newton per meter, and so is this Newton per meter. Because we are multiplying force and distance, right? Okay, apologize for that. Okay, anyways, coming back to this. And there is an answer here, 380 Newton meter. And you would happily put your answer as D. So this happens if you did not realize that 1.6 is actually not perpendicular to the weight. So the reason I picked this question is actually to make you more aware of whether the distance is perpendicular or not. Don't straight away take 1.6 times weight. Check if it's perpendicular or not. Check if the weight or the force, any force, is perpendicular to the distance based on the question. Okay, yeah, so that's about it for today's question. Also, this is actually the wrong method, yeah? The wrong way. So don't do this. This both, okay, let me mark in green. These two are the correct one. Okay. So yeah, that's about it for today's video. I hope this gives you a bit of clarity and awareness to know the force has to be perpendicular to the distance, and not necessarily they always give you the perpendicular distance. Sometimes you gotta find. Same goes to the forces as well. So that's all for this video. I'll see you in the next one. Bye bye.